I've been always fascinated about finding rules that govern nature. In nature, symmetry is all around us. We just have to look for it. We are just surrounded by geometric shapes, geometric pattern, symmetric pattern. If we look at flowers or snowflakes or honeycomb, broccoli, Romanesco broccoli, all these shapes are symmetrical, so we can draw all these lines and divide these natural things in small units. Also in the bigger scale, we can appreciate symmetry, like for instance in the hurricane or the solar system. Everything rotates around symmetric shapes. This is something that is known as the law of beauty, because symmetry is harmony. There are different types of symmetry according to the number of times a unit can be repeated. If you have only a left and right side, that is described as a bilateral symmetry, so two mirror images. If you can draw a line that divides the body multiple times and giving you mirror images, that is a radial symmetry. You cannot identify a left or right side or up and down body. The first to come around was radial symmetries. For instance, starfishes. We can easily divide their body at least 5 times in identical halves. It was important for them to have this geometric feature in order for them to promptly react from stimuli coming all over their environment. During evolution, this symmetry has evolved through polarization of the body, pulling all our sense organs on one pole of our body. Going from radial shape to bilaterally symmetric shape like us has been a fundamental acquisition, a feature that has allowed spreading of different species around the world. Our human body is classified as bilaterally symmetric, but this bilateral symmetry is not perfect. We are not symmetrical in the inside. Also, how we use our left and right hand is linked to asymmetry in our brain. And our brain itself is slightly asymmetrical, having some lobes that are bigger on the right or left side. So, and these are all important breaking of symmetry that are functional for our body. Breaking symmetry is as important as making symmetry in biology. For instance, one example, a crab that only the male has a different left and right claw, and that is a mating adaptation. Or some birds that have changed the shape of their beak for feeding specifically in particular ways. Or the soulfish, breaking the symmetry, the bilateral symmetry, specifically in the ice region, because of his way of living on the bottom of the seafloor. So establishing something that is geometrically perfect and breaking it, both are essential in biology. Symmetries are not always fixed for life, but they can transit during the lifespan of an organism or during the development of an organ. And this is the case of the organ we study in plants. So that undergoes a symmetry transition from bilateral to radial symmetry, which is extremely rare in nature. So here we are looking at inflorescence, so many flowers displaying symmetry, and every organ of the flower is set up in a particular type of symmetry. By genetic manipulation, we can break this radial structure and understand the mechanism behind. So this is how the normal female reproductive structure looks like. So it undergoes symmetry transition from bilateral to radial symmetry at its top. And this is how the mutant looks like, because it doesn't undergo symmetry transition, it stays bilateral, showing this cleft, and this is catastrophic for plant reproduction. These type of mutants don't produce seeds. If we understand how we can break symmetry, we can also understand how symmetry works. And this would allow us to understand more about science and the world around us. Breaking symmetry in our body can really lead to malformity and diseases. And one such example is the bicuspid aortic valve disease, that is the most common congenital heart disease in humans, and is caused by a simple change in the symmetry of a small structure in the aortic valve, so that becomes bilaterally symmetric with 2 flaps instead of 3, very detrimental for the flux of blood around our body. We are drawn to symmetric shapes by some mechanism in our brain. People seem to be more attracted to symmetrical faces instinctively. For instance, women's faces become more symmetrical when they go through ovulation, and this is perhaps important to attract. Symmetry can be easily recognized in architecture as well. We can experience many different points of view when walking around a building like this cathedral. But we are really drawn to the central aisle, the point at which the mirror image of left and right meet. And when we stand below the dome, the meeting of the 4 axes, we know we have arrived to a very special place. So when things are not symmetrical in architecture, they perhaps are more upsetting for our concept of beauty. One such example is in the Brussels City Hall, where the building is not perfectly symmetrical, so its left and right side are not mirror images of each other. As the legend says, the architect wasn't planning for it, and when he discovered this asymmetry, he was so devastated that, unfortunately, he decided to kill himself. It's easier to understand the importance of symmetry in art, because there is a requirement of balancing objects and the feature to make it harmonious. One example is Leonardo da Vinci. In The Last Supper, he positioned Jesus Christ right in the middle and balanced the other feature of the painting on the left and right side to create harmony, but also to drive our attention towards the most important part of the art. Symmetry is fundamental, is important for every creature on Earth. It's important in biology, but also important in other disciplines, in physics, in mathematics, in chemistry. It's important at every level, across scales. So it's important for us to understand the principles, how it works, to explain the bigger questions in life.